In this video, I propose a learning sciences research agenda around the proposition that tablets can be used as tiny tabletops. I connect my current work on the proportion tablet application to my previous work on the DigiTile tabletop application to provide a concrete case of a tiny tabletop research agenda. Multi-touch tablet sales are set to eclipse PC sales in the near future. Unfortunately, current efforts to bring these into the classroom center around didactic instruction. How can we, as learning scientists, provide a more active alternative? Taking a step backwards, it is worth noting that tablets are part of a larger trend, away from desktop computing towards interactive surfaces. Interactive surfaces have several useful advantages. First, they enable direct input. In comparison to using a mouse to control a cursor, the cognitive distance between intent and execution is shortened. This advantage is particularly relevant for younger children. Second, they support multiple access points. This enables multi-touch gestures, such as pinching to zoom. Furthermore, the touch points can be split among multiple users. Already, there is an established literature on interactive tabletops supporting co-located collaborative learning. Tablets also support direct input and multiple access points. Can they similarly support co-located collaborative learning? Inspired by the research on the DigiTile tabletop application, we created the proportion tablet application to realize and research that possibility. DigiTile is a port of DigiQuilt to the Diamond Touch interactive tabletop. It is a construction kit that allows two learners to work together to design colorful mosaic tiles in order to accomplish various mathematical challenges. Two users, standing side by side, work together by placing pieces from the left and right palettes to the central tile. Pieces can be moved to the bottom work area to enable rotation. The tool provides real-time feedback on when fraction of the tile is a certain color. When finished, for instance, this tile will be half red and half yellow. In a research study, participants worked on three challenges. First, to familiarize themselves with the software, they replicated the pattern shown here. Second, they created a 4x4 tile that was 3/8 orange and 3/8 brown. Third, they created a 5x5 tile that was 1/10 red, 2/10 blue, 3/10 yellow, and 4/10 green. The DigiTile using groups perform significantly better than a control group on a pre/post test of fraction understanding. To better understand why DigiTile was successful, we conducted a careful video analysis of three successful groups. Remarkably, each group showed individual group dynamics, stable across the challenges. That DigiTile was able to accommodate all three demonstrates the flexibility of tabletop interfaces. The large interactive surface allowed learners to work concurrently. Due to visible hand and arm movements, participants were able to easily monitor their partner's contributions. Children fluently used verbalization, gesture, or a combination of the two to communicate. They smoothly switched between acting and observing. Based on this understanding, we designed the proportion tablet application. Proportion is a tool to learn proportional reasoning. Two children work together, seated side by side, to complete a sequence of increasingly difficult problems. For each problem, learners must resize the orange and blue columns so that their heights are in proportion to their numerical labels. Proportion employs different tools and real-time feedback to support learners. Without support, learners must learn to estimate the ratios. With a fixed 10-position grid, learners can precisely target locations, thereby using their mathematical understanding of the task to solve problems. With relative lines that expand based on the locations, learners can use counting to solve problems. They can also use embodied strategies such as matching up the grid patterns. The lines can also be labeled. In this fraction example, a viable strategy is to arrange columns so that the whole numbers, i.e. 1, are at the same level. The app provides real-time feedback on task progress. Within a certain zone, the arrangement is declared close. Within a smaller zone, the arrangement is declared correct and the next problem is shown. The zone tolerances are fine-tuned to match each problem. In addition, after 1 minute, learners are given directional feedback. Thus, They do not need outside assistance to make progress on particularly difficult problems. In addition to these basic features, the app uses 2 collaboration scripts to promote verbalization. If a problem takes a long time to solve, learners are prompted to verbally reflect on why the solution they finally arrived at is correct. To prime learners to understand new concepts, a productive failure script has them work on a difficult problem one side at a time without immediate feedback. If learners cannot solve the problem after several attempts, a canonical solution is provided. The research will focus on 2 broad topics: how children communicate to collaborate and equity of collaboration. The DigiTile work demonstrates how well children can use verbalization and gesture to communicate. Here we try to tease apart the 2. Tabletops have also been shown to promote equitable collaboration. This may be at least partially due to their large size, where access becomes an issue. With its left and right columns, proportion provides an implicit cue to interface ownership to the 2 participants. Do they follow this implicit cue? What happens when the convention breaks down?